So students, now we are going to start our 45 problem assignment on alternating current. First is this: two cables of copper are equal lengths. One of them has a single wire of area of cross section A, while other has 10 wires of cross sectional area A by 10 each. Give their suitability for transporting AC and DC. In DC, distribution of current is uniform, but in AC, it is mostly around the circumference. So if we are going to transport alternating current, we need more circumference. So we will prefer 10 thin wires. So for AC, only multiple strands for AC, single strand for DC. So for first, we can go only multiple strands for AC. For DC, there is no problem. It is uniformly distributed. So for DC, you can use 10 or you can use 1, no tension. But for AC, we will prefer multiple strands. So we are going with option A. Second problem. It is from 1994 AIPMT. In an AC circuit, just we saw that RMS value is 1 upon root 2 times the peak value. So we are going with D option. C. A capacitor of capacity C has reactance X. If capacitance and frequency become double, the reactance will be, we are saying that capacitive reactance is X. But we know that what is the formula for X? 1 upon omega C. What is omega? 2 pi F. F is frequency. What we are going to do now? X is changing because we are doubling the reactance frequency and doubling the capacitance. 2 is 2, pi is pi. F become 2F, C become 2C. So what we are getting? We are getting 1/4 extra with 2 pi Fc. It means old value of X divided by 4. So we will go with option C. Next, the time constant for CR circuit is CR circuit's time constant. It is CR and you can calculate dimensionally also. What are dimensions of C into R? We know that C into R means, C means Q by V. Q is equals to Vc. And R means V is equals to IR. V is equals to I into R. So R is V upon I. But Q is IT. So what we are getting? Time. So remember, CR is known as time constant of CR circuit. Next, fifth problem. It is from 1994 AIPMT. The current I in an inductance coil varies with time t according to the graph given below. Which one of the following graph gives the variation of voltage in the coil with respect to time? It is an inductance coil. What is happening in an inductance coil? Voltage is always leading the current. Voltage is always leading the current. So that's why voltage decreases continuously. So we will go with option A. Next, It is from 1995 AIPMT. When the key K is pressed at time t is equals to 0, then which of the following statement about the current I in the resistor AB of the given circuit is true? When you press the key, capacitor was not charged. Charging starts at that time. So at t is equals to 0, what will happen? Whole current will pass through capacitor. Whole current will pass through capacitor because it is in charging procedure. So in the path of current, there is only one resistance of 1000 ohm. So I is equals to, at t is equals to 0, the value of I is V upon R, 2 upon 1000 means 2 milliampere. When it will charge, after that, no current will flow through this branch when it is fully charged. Now it will go through this 1000 ohm resistance. So now value of I will be 2 upon R plus R, 2000 means 1 milliampere. So at t is equals to 0, I was 2 milliampere. With time it goes to 1 milliampere. So we will go with option B. The sixth option B was correct. Seventh, in the circuit given in figure 1, it is from 1999 AIPMT. In the circuit given in figure 1 and 2 are ammeters. Just after key K is pressed to complete the circuit, reading will be, just we press the key, current will start to flow through the circuit, but capacitor was uncharged. Now it will start charging, so whole current will pass through the capacitor. So what will be happen now? Just like previous problem, whole current will go through first ammeter towards C. So reading of 1 will be maximum and 2 will be 0. After that, when it is fully charged, no current will pass through 1, then the reading of 2 will be maximum. But when just after key K is pressed, reading of 1 should be maximum, so we will go with option D. Eighth problem. It is from 2004 AIPMT. A coil of 40 Henry inductance is connected in series with a resistance of 8 ohm, and the combination is joined to a terminal of a 2-volt battery. The time constant of the circuit is, we know that in LR circuit, remember, in LR circuit, time constant is L upon R, and in CR circuit, time constant is C into R. So L is given, R is given. L is 40, R is 8. So we are getting 5 seconds. So we will go with option A. Eighth A option was there. Ninth, it is from 2005. In a circuit, LCR are connected in series with an alternating voltage source of frequency F. The current leads the voltage by 45 degree. The value of C is, just we discussed the circuit, it is LCR. Current leads the voltage by 45 degree. Means XC is greater than XL. So it is XC minus XL. It is R. It is XL minus XC. It is Z. They are saying current. It is current. Leads voltage, it is the direction of voltage, by 45 degree. So you can see that 1045 degree is equals to, it is XC minus XL. So 1045 degree should be XC minus XL divided by R, perpendicular upon base. 45 means 1. It means R should be equal to XC minus XL. What is XC? 1 upon omega C. XL, omega L. It means 1 upon omega C is equals to R plus omega L. R plus omega L. What is omega? Omega is 2 pi F. Take omega on that side. So 1 upon C is equals to, omega means 2 pi F. R plus omega L. Omega is 2 pi F. So what should be the value of C? It should be 1 upon 2 pi F into 2 pi FL plus R. So we are going with A option. We are going with A option. Next, it is from 1990 AIPMT. An inductor may store energy in, I told you, in inductor energy is stored in magnetic field and it is in form of magnetic energy. So we are going with option C. 1991 AIPMT. A 100 millihenry coil carries a current of 1 ampere. Energy stored in magnetic field is, we have the formula, half Li square. Only we have to take care of units. Unit of L is millihenry, means 10 to the power minus 3. What is current? 1 ampere, square of 1 is 1. So what we are getting? 2 0 cancel with 2, 1 by 2 means 0.5, so it will become 0.05. So we are going with C option. Next, in an AC circuit, the current following is I is equals to 5 sin 100t minus pi by 2. Current is lagging behind by pi by 2, means L circuit. A and the potential difference V is equals to 200 sin 100t. The power consumption is equal to, since power factor is 0, phase difference is pi by 2. Phase difference is pi by 2. So what is power factor? cos phi, it will become 0. So power consumption, which was IRMS into VRMS into cos phi, it will become 0. So we will go with option D. 12th D. 13th, it is from 1997 AIPMT. In an AC circuit with phase voltage V and current I, the power dissipated is phase voltage V and I. It means not given what is the phase angle, because power is IRMS, VRMS into cos phi, but phi is not given, so it depends only on phase angle between V and I. Power factor was not given, so we are going with option B. It is from 2002 AIPMT. For a series LCR circuit, the power loss at resonance is, we know that what is happening at the time of resonance, it is LCR circuit. R is there, L is there, C is there. It is a case of resonance. It means XL and XC are equal, and XL minus XC, it will become 0. So it means total current in XL and XC, voltage 0 means total current 0. So power will only loss is in resistance, so it should be I square R. No power consumption in L and C at the time of resonance. So power consumption only in resistance. So we are going with option C. 15th, it is from 2006 AIPMT. A coil of inductive reactance 31 ohm has a resistance of 8 ohm. It is placed in series with a condenser of capacitive reactance 25 ohm. The combination is connected to an AC source of 110 volt. The power factor of the circuit is. What is the formula for power factor? Power factor is always R upon Z. What is the formula for Z? It is under root. When all components are there, R square plus XL minus XC whole square. They gave us XL. What is given? XL is given. Inductive reactance 31 ohm. R is given. No, what they are saying, capacitive reactance is given, but they are saying combined, the coil has resistance of 8 ohm, coil have resistance of 8 ohm. Yes, R is 8 ohm, and that coil has inductive reactance 31 ohm. Capacitive reactance we have 25 ohm. So we can calculate Z. What is the value of Z? Root of 8 square means 64 plus XL minus XC 6. 6 square is 36. So Z we are getting 10. So what is power factor? R by Z, 8 by 10. means 0.8. Power factor is 0.8. So we are going with option A. Next is from 2008 AIPMT. In an AC circuit, EMF and current at any instant are given by this. It means voltage is leading, but not leading by 90 degree. It means it is LR circuit or LCR circuit, which XL is greater than XC. But anyhow, we know phase difference. What is phase difference? Phase difference is phi. So power factor is cos phi. So average power consumption 1 upon ERMS into IRMS into cos phi. Average power consumption is, we know the formula. What is ERMS? E naught by root 2. What is IRMS? I naught by root 2. Cos phi is cos phi. So what we are getting? E naught I naught divided by 2 cos phi. So we are going with option A. 17th. It is from 2009 AIPMT. Power dissipated in an LCR circuit, series circuit. We know that what is power? ERMS. Power, average power means ARMS, IRMS into cos phi. IRMS is not given in any option. So to IRMS we are writing ERMS, Ohm's law, I is equals to E upon R. When we are using more than one components, resistance means impedance, and cos phi always R by Z. So what we are getting? ERMS. It is given epsilon square into R divided by Z square. Z square means no need to write under root, R square plus XL minus XC whole square. So we are getting epsilon naught square R upon R square plus L omega minus 1 upon C. So in 17th we are going with D. 18th from 1994 AIPMT. And series LCR circuit is connected to a source of AC current. At resonance, the phase difference between the applied voltage and the current in the circuit is. What is happening at the time of resonance? At the time of resonance, XL and XC becomes equal. Means no XL, no XC. It is current. In case of R, it is voltage, VR. If XL is greater than XC, voltage will lead. If XC is greater than XL, current will lead. When both these are equal, current will move with same phase with R. So phase difference should be 0. So for 18th we are going with B. 19th, it is from 2000 AIPMT. The value of quality factor is, quality factor we are saying to omega L upon R. So it is A option is correct. Omega L by R is known as quality factor. Next, it is from 2006 AIPMT. A transistor oscillator using a resonant circuit with an inductor L and a capacitor C produces oscillation of frequency F. We know that what is at the time of oscillation means resonant frequency, and resonant frequency is given by 1 upon 2 pi root LC. They are saying it was F. If L is doubled and C is changed to 4C, what is the frequency now? L is doubled, means 2L. C is changed to 4C. Now this 8 is extra. 8 means 2 root 2. Take 2 root 2 out of the expression. So what we get remaining? 1 upon 2 pi root LC, means old resonant frequency divided by 2 root 2. So we are going with option A. For 20th we are going option A. 21st, what is the value of inductance L for which the current is maximum in series LCR circuit with C is equals to 10 microfarad and omega is 1000 per second. It should be 1000 radian per second. We know that current will be maximum at the time of resonance, means when XL is equals to XC. What is XL? Omega into L. What is XC? 1 upon omega C. So L should be equal to 1 upon omega square C. What they are saying? Omega is 1000. It should be radian per second, 1000 into 1000. C is 10 microfarad. 10 means 10 into 10 to the power minus 6 farad. So plus 6 and minus 6 cancel with this. Multiply and divide by 100. So what we will get? 100 upon 1000 Henry means 100 millihenry. So we are going with option D. 21st we are going with option D. 22nd, the amplitude of an alternating voltage is 120 volt. What will be its RMS value? We know that ERMS means E naught divided by root 2. What is the value of E naught? 120. Root 2 means 1.4. So 1200 from 4 by 14. 600 by 7. 7 8s are 56, 40. So nearly we are getting, actually it is 1.414. So we are getting 85, so we will get 84.8. So we are going with A option, 22nd A option.